All right. You may see any of the problems on there. Okay. All right. Now, we're going to let this be u. Okay, that's my u. So u is equal to 1 minus z. So my du dz is negative 1. All right. Which means when I flip it, dz is still negative 1 du. Okay? So I'm going to go back in and plug in some stuff that I have. All right. I have z plus 2. Still there. I have square root of u. Now dz on the end actually turns into negative 1 du. All right. Here's the problem that I run into. Usually at this step, something cancels. Okay, that's the problem that I'm running into. So, because nothing cancels, I have to substitute again. I need to get z, this is the problem. I have to get z in terms of u. So I'm going to go back to our original u equation, and I'm going to solve that for z. So what does that look like? U equals 1 minus z. I'm going to add z to both sides. So I get u plus z equals 1. And then subtract my u, and I'm writing all this out. You don't really have to do that. But you get 1 minus u for z. Now you have something that you can plug in for z. That is in terms of u, which is what you need to integrate in terms of u with that du on the very end. So that gives me the integral of 1 minus u plus 2 times the square root of u times negative 1 du. Now everything is in terms of u, and you're good to roll. So doing some simplification here. All right, you got negative 1 plus 3 times square root of u. All right, times negative 1 du. So what I'm going to do is I'm going to go ahead and take this negative 1 out front of everything. So I'm going to think of this as the negative integral negative u plus 3 square root of u du. Now, can I write that square root of u as u to the 1/2 power? Let's do that instead. Okay? So now, in order to take the integral, to use the anti-power rule where we do like plus 1 over the power plus 1, all right, we need to just have something with only powers, not a couple of things. So I'm going to just distribute this in to both pieces. So you have u to the first, which is actually 2 over 2, right? So that is going to give you the negative integral of negative u to the 3 over 2. Plus, you got 3 u to the 1/2. Okay, du. Now you're ready to take the integral. You're actually ready to do what you always have done. All right, so what does that look like here? You got your negative outside of everything here. All right, outside of all of that. So you have negative u to the 3/2 plus 2 over 2 is 5 over 2 all over 5 over 2. Okay? Plus, you got 3 times u to the 3/2 all over 3/2. Okay? Plus c. All right? Now you got a couple things you got to flip. I'm gonna come right here and write it. All right. You got your negative outside everything. You flip the 5/2 up, so it's negative 2 over 5. U to the 5/2. Plus 3 times, I got to flip my fraction up. So 2/3. U to the 3/2. Plus my C. Don't forget that. Okay? So now, everything's good. All right? I'm gonna go ahead and take this negative inside everything. So that's 2/5. What's my U? My U is actually 1 minus Z to the 5/2 power. I'm going to take my negative into the 3. 3 times 2 is 6. 6 divided by 3 is just 2, right? So subtract 2U. U is 1 minus Z to the 3/2 power plus C. Okay, so that one had a lot of stuff going on, but it's just working with our algebra there. 25. So when you look at these types of problems, the biggest thing for y'all to notice is if it's sine of something raised to a power, that's actually like sine of theta to the 6th power times cosine of theta d theta. Okay? So we pick our u usually with what's in parentheses. So I'm going to let my u actually be sine of theta. Okay? So I'm going to pick my u to be sine of theta because the derivative of sine is cosine. Okay? So my du...
You said difference of sine is cosine?
Yeah.
Positive cosine?
Yes.
Caleb, get out, Caleb. Get out.
The derivative of u is cosine. If you're thinking about, like, the derivative of cosine is negative sine, but that's not what we're asking. We're asking what's the derivative of sine. Derivative of sine is cosine. Okay? So now when I flip this thing around, I get d theta is 1 over cosine du. Okay? Now, how does that help us? We have u to the 6 times cosine of theta times d theta now turns into 1 over cosine theta du. Luckily, our cosine thetas cancel each other out. Okay? So now it's just, you don't really have to write this second step out, but I'm cleaning everything up. You have the integral of u to the 6 du, which is really, really easy to take. We know from the anti-power rule, it's just u to the 6 plus 1 is 7 all over 6 plus 1, which is 7 plus c. All right? So now all it is just going back and plugging in what u is. So you plug in whatever that is. Well, u happens to be sine to the 7th power of theta all over 7 plus c. And that would be it for that one. So, what we got to do here is we got to pick our u. Okay? So we got to pick our u. Yeah, I usually pick that because you want that to be e to the u because you know the integral of e to the u is just e to the u. All right? Something simple. So we're going to let u be x to the 3rd plus 1. We're going to try that out. See what works. See if it's good to us. All right, du dx is now 3x squared, and the 1 goes away. Nice. So we flip this thing around, 1 over 3x squared du. So now we do have something that cancels. So you have the integral of x squared times e to the u times dx is actually 1 over 3 x squared du. So something does cancel. The x's cancel, which was our whole goal in substituting. Okay? Now, what I like to do to clean up my problem is bring the 1/3 all the way out. E to the u du. So now that makes it really, really easy to take the integral, because the integral of e to the u is just e to the u. So you have 1/3 e to the u plus c. So plug it back in. That's 1/3 e to the x to the third plus 1, and then plus c on the end. That would be it. So in 73, you have a radical in the bottom. Okay? So I'm going to let the bottom part without the radical be my u. All right? So u is going to be t plus 1. Okay? So that kind of helps me out. I got t squared plus t all over the square root of u. Okay? So du dt is 1, which means dt is equal to 1. Now, problem is that doesn't cancel anything out, does it? All right? So we have to get t in terms of u. Correct? So over here, t is actually equal to 1 minus u. Right? So if we do this, that's actually going to give us 1 minus u squared plus another 1 minus u all over the square root of u du. Okay? So you could bring it up and multiply. You actually need to FOIL this out. So that's going to end up giving you 1 minus 2u plus u squared. Then you still have your plus 1 minus u. All right, all over u to the 1/2. Okay, or we could bring it up and multiply by u to the negative 1/2. Okay, so this isn't too terrible right here. I've got 1 plus 1 gives me 2. So you have the integral of 2 minus 3u plus u squared times u to the negative 1/2 du. So now you got to distribute that negative 1/2 into everything. All right, so that gives me 2u to the negative 1/2 plus 3u to the 1/2, because negative 1/2 plus 2 over 2 is just 1 over 2. And then plus u to the 3/2. Okay? And so now that's not too. This should be a minus 3u, not a plus 3u. Yeah. So when you take the integral of this, that's 2. You got u to the negative 1/2 plus 2 over 2, so that's 1/2 all over 1/2 minus. All right, minus 3 u to the 3/2 all over 3/2 plus u to the 5/2 all over 5/2. So now we got to flip some stuff around. 2 times 2 over 1 u to the 1/2 minus 3 times 2 over 3 u to the 3/2 plus 2/5 u to the 5/2 plus c.